In this nugget, you and I are going to take a look at a few additional functions and features that are available with a vSphere distributed switch. I'd like you to imagine that the networking team that does the physical networks at our company has come to us and they said, hey, we have these new features we'd like to integrate and connect to and work with the vSphere environment. Is that possible? And one of the challenges is for us, if we're not aware that a feature exists, we may not be able to go ahead and turn it on. So in this nugget, we're going to touch on each of these features that are available as part of a distributed switch. And if the distributed switch had a theme song, it might go something like this. Anything you can do, I can do better. Because it can do everything the standard switch can do regarding features, plus much, much more. The first feature I'd like to talk about is Link Aggregation Control Protocol. It's an industry standard, and with Link Aggregation Control Protocol, we can take two or more interfaces and bind them together to make one logical pipe. For example, here on this distributed switch, we have two uplinks at the moment. And these would be connected in a production environment out to a physical switch. So let's say we have physical switch A. So here's the ports it's connected to. And one of the problems of having two separate interfaces is that if these are both in the same VLAN, spanning tree is going to go ahead from the switch's perspective and it's going to block on one of the two ports. Now, we don't have to worry about vSphere doing blocking because it's not running spanning tree. However, if we train this switch and our vSphere environment that these are actually one logical group, they call a link aggregation group, it can treat them as one, and it's link aggregation control protocol that can allow that to happen. So on the distributed switch, we could create a link aggregation group. On the physical switch, whether it's a Juniper or a Cisco or an HP, we'd configure the parameters there to support the link aggregation control protocol. And it's a match made in heaven. With link aggregation control protocol, one side can be active and the other side can be passive, or both sides can be active. That also works. And if you're working in a Cisco environment where a switch A is a physical Cisco switch, they often refer to this bonding of the links as ether channel. So the feature of link aggregation control protocol is available as a feature on a distributed switch that is not available with a standard vSwitch. Another feature that's available with the distributed switch is the concept of a private VLAN. And the concept of private VLANs is covered in several different courses at CBT Nuggets. And one of the benefits of private VLANs is the fact that we can have an IP subnet, but at the same time we can have isolation of groups of those devices on that same IP subnet through the implementation of private VLANs. And the feature of setting up and creating private VLANs is available as a feature on a distributed switch. NetFlow is a fantastic feature that we can use to gain information on what the heck is traveling across our network. For example, what's the most used protocol? Who are the top talkers based on IP addresses? And many more details like that can be collected through the use of NetFlow. And on a distributed switch, it does support NetFlow. So we can set it up, collect that information, send it over to a NetFlow collector on our network so we can see what types of traffic and what quantity of that traffic is flowing across our networks. With port mirroring, we can replicate the traffic at one part of our network to send it over to another. So for example, if we're doing troubleshooting or analysis, we can collect the data we need via port mirroring so we can analyze it usually with a protocol analyzer. However, that information also might be used in conjunction with an intrusion prevention or detection system that is also analyzing the data on our network. The security options are similar to what they are on a standard switch, which include the ability to do promiscuous mode, along with the option of allowing a virtual machine, a guest operating system that has changed their MAC address, to receive frames at that new MAC address, as well as to send frames with that new source MAC address. And those same three features regarding security are found on a standard switch as well, except the defaults are different. On a distributed switch, the default is reject for all three of them. Traffic shaping, the slowing down of traffic, is also very similar to that on a standard switch, except it adds a direction. What do you mean, Keith? It adds a direction. You mean like one direction? I mean like two directions. A standard switch will only slow down ingress traffic. That means traffic that is coming from a virtual machine into the switch. And on a distributed switch, it also can go ahead and slow down egress traffic. And that would be traffic that is leaving the switch going to a virtual machine. So we can do it ingress or egress with the traffic shaping on a distributed switch. Another option we have with a distributed switch is trunking. Now, we have some trunking with the standard switch. For example, if we have a VM port group, let's say we have a VM port group called Group 5. And regarding the details of that port group, we specify that it's part of VLAN 777. Well, what happens as that traffic goes out to the outside world, the switch, the standard switch, would automatically tag those frames as it goes over the trunk with the NATO 2.1Q tag of 777. So the standard switch can do all that. However, what also happens with a distributed switch is we also have the ability to tag frames as they're going out to the virtual machine. So if we have, for example, a Windows server that is connected to our distributed switch, if this server is configured to accept and understand 802.1q tags, we can actually trunk from the switch to the virtual machine. So effectively, we have the ability to have a trunk between the Windows server and the distributed switch. In a Cisco environment, if we're connected physically over to a Cisco switch, it's very likely that CDP, Cisco Discovery Protocol, is running on that switch. So every 60 seconds, it sends a little love message saying, hey, here I am, and here's my name, and here's my management IP, and et cetera, et cetera. And it's a great way to help learn our topology and networking devices that are directly connected, especially if they're Cisco. Well, with the distributed switch, we can turn on that feature of CDP so we can send messages, or we can just listen, or both, which is a nice option to be aware of if you're connected to a Cisco environment and they happen to be using the CDP feature to learn network information. And you might be saying, well, Keith, what if this is not a Cisco switch? Is it going to support CDP? And the answer is probably not. But if it's a Juniper switch or an HP switch or some other vendor, it's very likely that they support the industry standard Layer 2 Discovery Protocol, and that's called Link Layer Discovery Protocol. So on a distributed switch, if we want to, we could enable that instead of CDP, and it would completely depend on what we're connecting to on the outside, what physical gear, and whether or not that device on the outside, that physical device, is using CDP or LLDP. In this nugget, we've taken a look at a few features of the distributed switch that are usually above and beyond what a standard switch can offer. Thanks for joining me in this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.